Okay, hello guys, welcome to Small Samuel Math Tutorials. So the today's lesson will be focusing on the derivative, and I'm just going to show you the ways and the hints on how do we solve the derivatives. So remember that if you're first, we already talked about the first principle and we explained everything there. So I will leave a link for that video for the first principle so that you can go to watch it so that we cannot leave you behind. So today, like I said, we are going to talk about the derivatives, right? So there are the things that you need to know before deriving. Like before deriving, you must remove the following things. What are those things? The first thing is to remove the square roots or the cube roots. In simpler terms, you need to remove what? The roots. It's either the square root, the cube root, or the fourth root. So meaning whenever you have the square root or any root, you need to do what? You need to remove them. I'll show you how do we remove the roots and write them in terms of the exponential, right? That is the A. And the second thing is if you have the brackets under your equation, you need to remove those brackets before doing what? Before deriving, right? And lastly, which is make sure your x is a numerator. Remember, sometimes you can be given 2 all over 2x. You can see that 2x is a what? Is a denominator. So you need to write it in a what? In a form that your x, it can be your numerator, right? So in simpler terms, you're going to write your x to be in the negative exponential form, right? So but then we'll talk about it. So now let's focus on the first example, which is f of x is equals to the cube root of what? Of x squared, right? So as we are given this thing, so we're going to check the things that we wrote there. The first thing, do we have the roots there? Yes, we do have the roots. We have what is the cube root, so we need to remove it, right? How do we remove it? So if you can check the keyword here, the square root of x is equals to what? X to the power of 1 all over 2. In simpler terms, from here we have what? We have 2, you see. So, and here we have what? We have 1. So in simpler terms, whenever we remove the square root and we want to write it in the terms of the exponential form, what we do, we take the exponent of the value from what? From the x or the term that we have and divide it by what? By the number from the root. Like we can see that this is the square root, so it's what? It's 2, and the number of the exponent here is what? It's 1. So that's why we wrote x to the power of 1 over 2, right? So from the second one, we can see that we have cube root of what? Of x. Like I said, at the numerator we write what? The exponent of the term which is under the root. What is the exponent there? We can see that it's 1, therefore it's going to be 1 all over what? 2, and then the denominator beside it's what? Is that it's either square root or cube root or fourth root. And we can see that here it's what is 3, that's why we divided by 3. Therefore we have 1 over 3. So for the fourth root, like I said, whenever we write it in terms of the exponential form, we write x, and then for the exponential form, we do what? The numerator is the value, which is the exponent of the value, which is under what? Under the root. We can see that here we have what? It's 1, right? That's why we write 1 all over, and then we check whether it's fourth root or cube root or what. And we can see that it's 4, that way we divide it by 4, right? So if we check here, how are we going to write it? We are going to write x, that is the first thing, and then we check what? The exponent of the term which is under the square root. What is that value? It's 2, right? So therefore we're going to write it. It's going to be our numerator. And then we said we divide by what? It's either the cube root or fourth root or square root. But then we can see here we have what? 3. Therefore this is going to be 3. So in simpler terms we have x all over x to the power of 2 over 3. So meaning x to the power of 2 over 3 is the same as the cube root of x squared, right? You saw that. Now we are done removing what? The square root. So now do we have the brackets? No, we don't have the brackets here. Okay, is our x value a numerator? Yes, we can see that this x value is a numerator, right? Because it's like x all over 2, all over 3, all over what? All over 1. We can see that 1 is the denominator here. So obviously anything divided by 1 is what? Is that term, right? So now we have x to the power of 2 over 3. So now we can do what? We can derive, right? So whenever we derive, we know that we are going to say this is the sign of that you are deriving or you've already derived. So we're going to take the exponent the way it is and then multiply with what? With the coefficient of what? Of the term. We can see that this term is what? It's x to the power of 2 over 3. And what is the coefficient of this term? What is the number which is it's here from the first term? It's what? We can see that it's 1. Therefore, we're going to multiply that 1 with what? With 2 over 3. Therefore, we're going to have obvious 1 multiplied by 2 over 3 is what? It's 2 over 3. Therefore, we write that x the way it is. After writing x, remember we are deriving, so we need to subtract the exponent with 1 always. So our exponent here is 2 over 3. So we have to subtract it with what? With 1, right? So therefore we are going to have 2 over 3 x. Therefore 2 over 3 2 over 3 minus 1, 2 over 3 minus 1, it gives us negative 1 all over 3, right? Therefore we are not done. The grade 12, we are not done. So we need to write this exponential, which is in terms of the negative to be positive. How? Remember that, let's say whenever we have let me write it here, I'll cancel it. Remember whenever we have 2x squared and we want to write our this fraction to be, or our x squared to be in the exponential or in terms of a negative exponential. Therefore we know that we need to do what? It's going to be 1 over 2. Then we take this thing the way it is. It's going to be x to the power of negative 2. I don't know you are aware of this, guys, which is that formula of whereby from the exponential formula, which it says a to the exponent of negative n is equals to what? 1 over a to the exponent of n. So we can see that here we have what? We have 1 over 2x squared, which is 1 over an. What is our n? Our n is the exponent, right? So therefore, whenever we want to write it in terms of the n exponential, we're going to do what? We're going to write our a. What is a? Is the constant, which is 1 over 2 minus what is our n? Our n is going to be 2. That's why we have 1 over 2x to the negative 2. So if we check here, we have x to the power of negative 1 over 3, right? So if we want to write it in this form, whereby we write 1 over an, it's going to be what? 2 all over 3, right? Therefore, we can see that we need to write what? Our x, which is a. Therefore, we're going to write our x here, which is a, and then our exponent, which is what? It's going to be, it's no longer going to be negative 1 over 3, but then what? 1 over 3. Let me write it correctly. So this is what we are going to have. So you can see that what we did, we just took this x and then we put it from where, from the denominator, and we obviously this x, it goes with what, with negative 1 over 3. Then we take it the way it is, and then the only thing that we're going to replace is what, we're going to replace that negative with what, with positive. Then we are done solving for this question. So now we're going to do the second example. Whenever we are given the brackets, right? So I'm just going to remove all these things because of the space. So if you have any question, you can leave a comment behind. Okay guys, now let's do the example 2. The example 2 is f of x is equals to x plus 2 all squared plus 2, right? So remember, from before we derive, we need to check all those three things, right? So do we have the square roots or cube roots, or do we have any roots there? No, we don't have the roots there. Therefore, we tick this one, means we're correct. Do we have the brackets? Yes, we have the brackets. So meaning we need to remove the brackets, right? So meaning we're coming to this step of removing what, the brackets. How do we remove the brackets here? Obviously, we just you can use a FOIL method, or what I like to do is x squared is what, it's x squared, and then x multiplied by 2 is 2x multiplied by 2, the unknown 2 which is outside, therefore it's going to be plus 4x, then 2 squared is what, it's 4 plus 2. You can use your method here guys. So therefore our answer is going to be x squared plus 4x plus 6, right? So therefore we come to the last one. Make sure your x is a numerator. All our x here, the numerator, right? So meaning we can now be able to do what, to derive. So when we derive, obviously we said we multiply the exponent with the coefficient of the term, and we can see that the coefficient of the first term, which is x squared, is what, is 1. So 2 multiplied by 1 is going to give us 2, therefore we write x. Then after we said what, after doing that, we need to subtract that exponent of the term with what, with negative 1 always. So with 1, so meaning 2 minus 1 is it is going to give us 1. Then we are done. Now we come to the second term. We have 4x. And then, like I said, whenever we derive, we do those steps. We multiply the exponent with the coefficient. We can see that the coefficient of the second term is what? It's 4, right? And the exponent is what? It's 1. Remember, there is a 1 here. So 1 multiplied by 4 is going to give us 4, right? And then after, we're going to say x. Yeah? Therefore, remember we said we subtract the exponent with what? With negative 1. So therefore we're going to have negative 1 here, right? Therefore, any number, whenever we differentiate a constant, remember a constant is a number which it doesn't have variables or the letters, right? So we can see that this 6 is just a constant, right? So whenever we differentiate a constant, the answer is always what? 0, right? So we are not done. We have 2x squared plus 4x to the exponent of 0, right? Anything to the exponent of 0 is 1, right? So meaning it's going to be 2x plus 4. This is the answer. So if even though you can take your calculator, press 100 to the exponent of 0, you're going to get 1. Anything to the exponent of 0 is 1. So now we are done with the second example. You can see that here, you just, after removing the brackets, things are easier for you to differentiate. Now we're going to do the last example, which is f of x is equals to 1 over x. I'm just going to remove these things that we wrote here. Okay, from the last example, we have f of x is equals to 1 all over x, right? So we are asked to derive this. So we're going to check all those three things that we need to check. Do we have roots there? Because the first one says remove square roots or the cube roots. Do we have roots there? No, we don't have the roots. Okay, that means we are safe. You tick it. Then you go to the second one, remove the brackets. Do we have the brackets there? No, we don't have the brackets, therefore we tick it. Meaning, the last one says make sure your x is a numerator. Is our x a numerator here? No, we can see that this x is a what? Is the denominator. So therefore we need to write it to be a what? Our x to be what? To be a numerator. How are we going to write it? Remember this formula of a to the power of negative n is equals to 1 over a to the power of n, meaning we can use this thing of the exponential laws to do what? To write this x in terms of what? To be the numerator, right? So f of x 1 all over x, right, which is f of x here, 1 over x. Remember I said this a, it's a what? It's the term which we're given here in terms of it can either be x or y, right? Which is under the denominator, right? And then what is n? N is the exponent, right? So in simpler terms here, we have 1 over a to the power of n, right? Where our a is equals to x, and where our n is equals to, what is the exponent of x here? We can see that it's what? It's 1. Like I said, that n represent what? The exponent. We have these values a and n, and then we want to write it in this format, right? So meaning it's going to be simple for us. We already have x and we already have n. So whenever we write it in that format, we are going to have, what is our a? Our a is x, right? And then minus, because of this negative, and then what is our n? Our n is 1, therefore we're going to have negative 1. Then we are done. Then now we can differentiate this, because we can see that now our x is a what? Is a numerator. Therefore when we differentiate this, like I said, we're going to do this, then multiply the exponent with the coefficient. It's going to be negative 1, because it's negative 1 multiplied by 1. Then we write our x. Therefore after we do what? We're going to subtract the exponent with what? With 1. So negative 1 multiplied by negative 1 is what? It's negative 2, right? Therefore we are done. But then we need to take this answer to where at least our exponent can be what? Can be in terms of a positive exponent. So how do we do it? Again, this is if you can check this, is the same as a negative n is equals to 1 over a to the power of n, the exponential laws, right? So therefore what is our a? We can see that our a is what? Our a is negative 1x, right? We can see that our a is negative 1x. What is our n? Our n is exponent, right? We can see that it's negative 2, right? So as we have a to the exponent of negative n is equals to 1 over a to the power of n. So meaning when we write it in this format of 1 all over a to the exponent of n, we are not going to have negative, but then it has to be what? positive. So in simpler terms, we are going to have 1 over a to the power of n, which is 1 all over, what is our a? Our a is negative 1x, right? And then what is our n? Our n is negative 2, right? We found that our n is negative 2, right? So, but then we don't want, but then from this formula, we don't have a negative here. So meaning we are going to just only write what? 2. So in simpler terms, we can just do this. Negative 2 divided by negative 2. Your negative divided by negatives. Therefore, we're going to have negative into negative 2, right? So this one is what? Is negative n. It's a negative n, which is this one. You can see that we have negative n, and our negative n is equals to what? 2, right? So meaning here for n, we are just going to write what? 2. And then we are done. So our final answer is going to be 1 all over. You see, that is how we do it. If there's something you didn't understand here, you can leave a comment behind so that I can explain it more. And then now let's talk about the tangent. Yeah, let's talk about the tangent. Okay guys, now let's do the tangent. The question says determine the gradient of a tangent of the graph f of x is equals to negative 3x cubed minus 4x plus 5 at x is equals to negative 1, right? So let's write down the solution. So before I write down the solutions, let me copy the steps that you need to do whenever you are asked to determine the gradient of a tangent of the graph, right? Okay guys, so in order to find the equation of the tangent, we differentiate the equation of the curve. When we are done differentiating the equation of the curve, we now substitute the value into the differentiated equation to find what? The gradient, right? So whenever you're given questions like determine the gradient of a tangent of the graph, right, at x is equals to negative 1. So the first thing that you need to do is to differentiate, meaning we're going to differentiate what here. Let me use different color. So meaning we're going to differentiate what? The function of the curve, which is negative 3x cubed minus 4x plus 5. And now believing that we know how to differentiate. Now we're going to remember that whenever we differentiate, we check this thing. Do we have the roots? No, we don't have the roots. Do we have the brackets? No, we don't have the brackets. Is our x a numerator? Yes, all of our x are the numerator, so meaning we can differentiate. Therefore, we know whenever we differentiate, we're going to have negative 9x squared minus 4, right? Therefore, this is the, after differentiating like this, we come to the, we said after differentiating the equation of the curve, substitute the value into the differentiated equation to find the gradient. So now we're given what? The value, which is x is equals to negative 1. So meaning where we see x, we're going to replace it with what? Negative 1, right? So therefore, the first derivative, we have x is going to be negative 1 is equals to minus 1 into negative 1 squared minus 4, which I believe is going to give us negative 30, right? Therefore, we are done solving this question. So you can see that whenever questions come like for the tangent one, don't panic. Don't panic, guys. Whenever they say determine the equation of the tangent, use the steps that are wrote here. You differentiate the equation that you are given, and then after substitute the value into the differential equation. Then that's it. Then we are done with the tangent and the derivative. So if you have a question, you can leave a comment behind, and let's not forget to subscribe, guys, if you find this video useful, and also like. Thank you.